Section 1. The Floating Brain. An introduction to your inner ocean. Imagine for a moment that you could hold your own brain in your hands. It would weigh about 3 pounds, or roughly 1.4 kilograms. That's a significant weight. So why doesn't your head feel like you're carrying a small melon on your shoulders all day? The answer is a beautiful piece of biological engineering. Your brain doesn't just sit inside your skull, it floats. It is suspended in a clear, watery substance called cerebrospinal fluid, or CSF. This internal ocean reduces the effective weight of your brain by over 97% to a mere 50 grams. It's the difference between holding a cantaloupe and holding a small egg. This buoyancy is the first clue to how incredibly important this fluid system is. This system of fluid isn't just a passive moat, though. It's a dynamic, flowing river that nourishes, cleanses, and protects the most complex object in the known universe. And the heart of this system, the source of these rivers, is a series of interconnected chambers hidden deep within your brain. These are the ventricles. Section 2. Welcome to the ventricles, the brain's hidden caverns. So, what exactly are these ventricles? The word ventricle comes from the Latin ventriculus, meaning little belly, which gives you a sense of them as hollow spaces or chambers. In the simplest terms, the ventricles are a set of 4 interconnected cavities located deep within the brain. They aren't solid structures. They are open areas filled with that crucial cerebrospinal fluid. Think of your house. It has rooms, and those rooms are connected by hallways. The ventricles are the rooms of your brain, and the CSF is the air and energy that flows between them. These aren't just empty voids. They are the manufacturing plants and distribution hubs for your brain's support system. There are 4 ventricles, arranged in a logical sequence to facilitate fluid flow. The choroid plexus in the ventricle walls makes CSF. Picture the choroid plexus as a tiny sponge or a cluster of grapes that constantly filters blood to produce fresh, clean CSF. Your brain makes about 500 milliliters a day. The system holds about 150. Replace 3 to 4 times daily. Section 3. The lateral ventricles. The twin giants. Let's begin our tour with the largest and most superior of the chambers, the lateral ventricles. There are 2 of them, a perfectly matched pair, with one residing deep within each half of your brain's cerebrum. They are the twin giants of the ventricular system. Their shape is complex and elegant, often described as a large, sweeping C or a ram's horn. This curve follows the developmental arc of the hemispheres, wrapping around deep structures. Each lateral ventricle has distinct parts: anterior or frontal horn, body posterior or occipital horn, and inferior or temporal horn. These 2 ventricles are the primary production sites for cerebrospinal fluid. Most choroid plexus lies here. They're divided by a thin membrane, the septum pellucidum, but each has a small opening, the foramen of Monro. Think of the lateral ventricles as bathtubs. The foramina of Monro are the drains. If there's a blockage downstream, these chambers expand. On MRI, enlarged lateral ventricles point to hydrocephalus. Their normal size signals pressure balance and buoyant protection. Have you ever seen a brain scan? The dark butterfly-like shape in the middle is often these very ventricles. Section 4. The central hubs. The 3rd and 4th ventricles. After leaving the twin lateral ventricles through the foramina of Monro, the cerebrospinal fluid flows into a single central chamber, the 3rd ventricle. This ventricle is a very different shape. It's a narrow, slit-like cavity in the midline, nestled between the 2 halves of the thalamus, the relay station for sensory information. If the lateral ventricles are sprawling lakes, the 3rd ventricle is more like a thin, deep canal or a narrow gorge. Its walls are formed by critical structures, thalamus, hypothalamus, and it contains a small amount of choroid plexus, adding a little more CSF to the stream. From the 3rd ventricle, it enters the cerebral aqueduct, about 15 millimeters long and 1 to 2 millimeters in diameter, tunneling through the midbrain. Picture it as the narrowest part of an hourglass. Because it is so slender, it's a common site for blockage, from tumors, inflammation, or congenital narrowing. Once through, it arrives in the fourth ventricle, shaped like a tent or a diamond, between the cerebellum and the pons and medulla. This hub is the last stop before release into the subarachnoid space. 3 apertures, 1 median, foramen of Magendie, and 2 lateral, foramina of Luschka, are the exit doors. Through these holes, CSF flows out to bathe the brain and spinal cord, a transition from internal river to protective ocean, completing the first phase of its journey. The precise engineering of these central hubs ensures the fluid gets exactly where it needs to go. The lifeblood of the mind. What is cerebrospinal fluid? We've talked a lot about the chambers, but what about the fluid that fills them? What exactly is this cerebrospinal fluid? At first glance, it looks just like water. It is crystal clear. It is colorless. It is mostly composed of water, but it is so much more. CSF is an ultra-pure filtrate of your blood plasma, made by choroid plexus, a highly selective barrier. It lets in water, essential salts like sodium and chloride, and some glucose, but blocks large proteins, blood cells, most foreign substances. This creates a pristine, stable environment. Unlike blood that fluctuates with meals or exercise, CSF stays remarkably constant. Think of it like a high-tech aquarium. Right temperature, pH, minerals, so neurons can flourish. Beyond stability, CSF protects, nourishes, and clears waste. The story begins in the choroid plexus, about 20 milliliters per hour, dripping like a steady faucet. New fluid circulates in the lateral ventricles, driven by production pressure, vessel pulsations, and cilia. It drains via the foramina of Monro to the third, mixes, then funnels through the narrow cerebral aqueduct, our critical bottleneck. Having squeezed through, it enters the fourth and exits via the lateral foramina of Luschka and the median foramen of Magendie into the subarachnoid space. It flows over brain and spine, then is reabsorbed by arachnoid granulations into the venous blood. Production and reabsorption perfectly matched. Imagine the sophisticated plumbing system of a modern city. Water flows through a network of pipes to every home. Now what happens if a major pipe gets blocked? Pressure builds behind the blockage, and the system fails. Flooding. The same principle applies to the brain's ventricular system. When CSF flow is obstructed or reabsorption fails, fluid accumulates. This condition is called hydrocephalus, literally, water on the brain. The buildup exerts dangerous pressure on delicate brain tissue. Obstructive hydrocephalus, a physical blockage. A tumor might press on the cerebral aqueduct. A congenital malformation might make a foramen too narrow, or scar tissue from infection or hemorrhage could block flow. Like a clogged drain, fluid backs up. The upstream ventricles, usually lateral and third, swell. Enlargement, or ventriculomegaly, is visible on scans. Compare normal versus hydrocephalus. Another type is communicating hydrocephalus. Ventricular flow is open but reabsorption fails, e.g. damaged arachnoid granulations after meningitis or bleeding. In some older adults, normal pressure hydrocephalus develops. Ventricles enlarge without consistently high measured pressure, causing difficulty walking, cognitive decline, and urinary incontinence. Treatment aims to restore flow and relieve pressure. A shunt, an artificial drainage tube, diverts CSF, often to the abdominal cavity. Another option is endoscopic third ventriculostomy, creating a small hole in the floor of the third ventricle. These interventions can be life-saving. It's easy to get lost in the anatomical details and medical problems, but let's zoom out and ask, why should you care about this system daily? The ventricular system and the CSF it produces are your brain's tireless 24/7 housekeeper. Every day, your brain's 86 billion neurons are working, firing signals, and consuming energy, generating metabolic waste. Without clearance, waste becomes toxic. CSF is the janitorial staff that never sleeps. Like a bustling city that quiets at night for cleaning, your brain deep cleans during sleep. During deep sleep, spaces between brain cells expand, CSF flows more powerfully. This glymphatic wash clears toxic proteins like amyloid beta. This is why a good night's sleep is vital for brain health. Your scheduled deep clean. Managing blood pressure protects tiny vessels in the choroid plexus and blood-brain barrier. Hydration supports CSF production. It's mostly water. Now you can visualize what's happening when you choose sleep over scrolling, understand headaches and pressure, and have informed conversations with your doctor. Your ventricles may be hidden, but their health is reflected in your clarity of thought, your memory, your overall well-being. They are truly your brain's best friend. We have journeyed through the hidden caverns, traced the river of life, and understood why keeping it flowing matters. Now, a clear, practical takeaway. While you can't directly control your ventricles, you can influence the system through simple, everyday habits. Your brain's plumbing is intertwined with your cardiovascular health. One of the most impactful habits is regular physical activity. Brisk walking, swimming, dancing. Movement improves circulation, supports CSF production and reabsorption, and gently pumps your internal ocean. You don't need a marathon. Consistency wins. Prioritize quality sleep, your non-negotiable maintenance window. Skimping is like letting trash pile up. Cognitive fog, memory issues, even long-term risk. Aim for 7 to 9 hours of quality sleep. So, here is your call to action. If you found this journey useful, please subscribe for more explorations into the world of science. More importantly, make a small change. What is one habit that helps your brain feel its best? Nightly reading to wind down, or a morning walk? Share your single best brain health habit in the comments. Let's create a community of ideas. And if you know someone who might benefit, share this with them. The ventricles may be hidden, but their story is worth telling.